when the students and the professor turned over wooden blocks, two salamanders squiggled for cover. They were redbacks and leadbacks. They're really the same species, but are named for the different colored stripes down their backs. Despite the similarity, they exhibit differences. The lead-backed salamander absorbs 2 times as much mercury as the redback. Brian Mangan, a biology professor at King's College, told me. Mangan has studied mercury in bass in the Susquehanna River and the crayfish that the bass eat, as well as in spiders that live along the river, and of course the salamanders. Mercury comes from natural sources, but also from burning coal and drifting down through the emissions of other man-made sources. It tends to concentrate at animals that are atop the food chain. And for years, the Pennsylvania Fish and Boat Commission has advised against eating more than 2 meals a month of bass caught from the Susquehanna because of mercury. Mangan theorizes, when talking about the salamanders, that the leadbacks and the redbacks might behave differently. They might have different diets or even lose their tails at different rates. Salamanders regrow tails if they're pulled off by potential predators. But when a tail falls off, Mangan figures some of the mercury goes with it. This summer and fall at Talon's Riverlands in Salem Township near Berwick, Mangan is teaching students how to do research outdoors. They're testing wooden blocks that he and other researchers commonly use on the ground to attract salamanders, and Mangan wondered if the practice changes the environment in ways that harm or help salamanders. Salamanders breathe through their skin, so their skin has to stay moist, and they like wet, cool areas. Mangan is curious about whether the wooden blocks keep the ground that they cover dry by diverting rain or whether they allow moisture to collect beneath them. He also wonders if the soil is cooler or warmer than the surrounding ground. To find out, he arrayed grids of 36 plywood blocks in 3 different areas of the Riverlands where he knows that salamanders live. 2 of his students, Neil Mayris and Kyle Sweats, lift up each of the squares 3 times a week. They insert a probe into the soil that measures temperature and moisture content, and they also check the bare soil between the squares. The work can be tiresome, but they take turns. If Neil measures the probe, Kyle writes down the results, and vice versa. Mangan tells the students to look for mold, insects, and other changes in the boards, as well as in the forests that they walk through. Open eyes and alert brains are as valuable to scientists as tools like soil probes and computers. Mangan started researching crayfish after seeing a horde of them scatter from a boat dock, and he studied a species of spider primarily because he wondered why it could materialize out of nowhere every July and became curious about its life cycle. Curiosity drives people like Mangan and his students to discover more about our natural world, and curiosity makes every trip we take along the trail more of an adventure.